Hello everyone. Today I will going to deliver a lecture on seepage. So this is the most important topics in seepage. Uh, if we want to understand deeply in soil mechanics, then we cannot avoid these topics. So before going to the deliver the deeply, then I have to discuss some. I want to show some formulas. As a formula, the total head loss HA minus HB, the number of drops MD. The number of drops mean how many the flow line, how many segmented in flow line. For example, this is the flow line, and it is segmented 1 2 3 4 5 6. So this is the number of drop, and the head loss of per drop, the per drop will be head loss H minus entry, number of drop. H is nothing but H is HA minus HB, and number of drop. Okay. Number 4, we can see here the number of flow of channel. That means how many channels water is going through how many channels. So we can see in this picture 1 2 3 4. So we can say the number of flow channel is 4. So coefficient of permeability K equal to CB MB and gamma W, and the single flow delta Q equal to K into H minus H2, or K equal to H minus delta H into H, which is we can say the head loss per drop H minus HD. And total flow rate, we have to memorize this formula K into number of drop H minus flow line, and gradient we have no H minus H2, which is means of the number of head loss, head loss per drop, H minus H2 minus ND divided by L. And this is the figure. We can see water is flowing here, and the line is flow line. We can see it is the vertical line, and it's also equipotential line. You can see here from it is the column or pile, you can say, from here. And when the intersect between flow line and equipotential line, the region you can say flow element. Okay. So this is the flood level, and this is the elevation level. So equipotential line equal to flow line plus 1. So equipotential line must be greater than flow line plus 1, and flow element is approximately square. So this is the flow element, and it will be square approximately. And flow channel between two adjacent flow net is flow line plus equipotential line. Okay. So you can see here KB equal to CB MB gamma W. So C equal to 0.197 H TR square TB, and TB equal to CB TB TR square, and TB equal to another formula of pi by 4 d U divided by 100 square, when U equal to less than 60%. When U equal to greater than 60%, then T will be low 1.78.0.993 log 10 minus U. So let's see the definition. Here's the seepage. So in this chapter we are consider the some example for which direct the application Darcy's law B equal to SI. So it is also comes from the permeability. As the Bernoulli's equation, we could know the H equal to Z plus 2B square by P by gamma. But in this topic we know the Darcy's law, which is B equal to gamma summation of I. That's why B equal to Ki. So the velocity is very low. That's why we'll use this formula. Okay. So what's required to calculate flow of the water through the soil? So flow net, we know the flow net is flow line plus equipotential line. What is the flow line? The flow line is a line along the which water particularly will travel from upstream to the downstream. This is the flow line. This is the flow line 1 2 3. Equipotential line Equipotential line is a line along which the potential load at the point is equal. So this is the equipotential. This is the we can say this is the pile or footing, and footing, the line is coming from the footing is called equipotential line. The equipotential line and the flow line intersect between, and the angle between equipotential line and flow line is 90 degree. Okay, so no, we know another, the flow line is approximately square, and flow channel between two adjacent flow, this is the adjacent flow, and uh, equipotential line, flow line plus 1. Flow net, what is flow net? The combination of number of flow line and equipotential line is flow net. The flow net is flow line plus equipotential line. So we can see here the total head loss H, HA minus HB, number of drop, we know the how many flow line, how many segments, how many divided in the flow lines, such as 1 2 3 4 5 6. So this is the number of drops. So this is the important. And head loss of per drop, H minus N3. H is nothing but H1 minus H2, and N3 is number of drop, and number of flow line, how many channels water is going through the how many channels. Here we can see in this picture 4, and coefficient permeability K, and the continuity equation is Q equal to AB, and this is coming from the continuity equation, and K equal to H1 minus H2, and delta KK is H1 minus H2 also, and this is also we can derive from the continuity equation. And the single flow, we can see delta Q equal to K equal to H minus HD, and flow rate K equal to K into H minus HD into number of HF, number of flow line, and gradient equal to H1 minus H2. So let's see let's see the example for clearly concept. F, this is the example 8.2. F, the example is F flow net is for flow around a single row of sheet pile in a permeable soil. There is a slow figure in this figure, and kz equal to 5 centimeter per second square. So we have to determine the how many height above the ground surface of water will rise if the pitchometer are placed at the point A and B. This is the point A, and this is the point B. And the total rate of the seepage through the permeable layer at the unit length. And third is the approximate average gradient at C. Okay, so this is our figure. We can see the this is the flood level, and we can see the here is the H1. We can see 5.6, and another was 2.2. The the distance is 4.1. It's given in question, and this distance is 3.8. These all are the given in question. So we can calculate the H1. H1 means this point. So let's calculate this point H1. This is the H1. We will calculate this H1. H1 HA, sorry, HA. H will be H1. This is H1, and H minus ND, number of drop. H is nothing but H1 minus H2. 5.6 minus 2.2, H1 into 1. We will going through from this point. That's why we will multiply 1 and found the value 5.6. On the other hand, we can see the same equation you can do from left side. So we can see H2. This is the H2, which is 2.2. H2 in 2.2. But now we'll go from this point. H minus H1 into number of drop. We know H minus H2, 5.6 minus 2 and 6, and the 5. Why we will multiply 5? Because 1 2 3 4 5. 1 2 3 4 5. This is segment is 5. That's why it is 5 from left side. On the other hand, we have multiplied this point 1 because it is the coming from left to right. On the other hand, we have calculated the left to right, right to left, then it will be 5. Okay, I hope that you can understand. All the result is 5.3. So we can see HB. In similarly, we can calculate now HB. This is the point of HB. this is the point of HB. So h1 minus h2 into 5. So I will give the 5 because we are going to the this portion. One, this portion means left to right. 1 2 3 4 5. So that's why we will multiply the 5. On the other hand, we can calculate the left side. So we can see this is the first. That's why we will multiply the 1. So all the result we have found HB 2.77. The total flow rate we know Q equal to H, Q equal to K into H divided by NT and HF. So H by NT is nothing but we have already said that this is the head loss of per drop. So head loss per drop in number of flow line. Head loss per drop number of flow line. So we know the H equal to H minus H2. So H minus H2, and flow line we know the 3 of flow line and found 0.06. And gradient A, we are calculating gradient point A. So it will be delta H minus H1 and delta H divided by L. Delta H is H divided by N by D. N by D is we know the flow head loss per drop. So head loss per drop H minus H1 minus H2 into ND divided by L. L is nothing but 4.1. This is given and found. This is the given in the figure 4.1, and that's why you will use 4.9 and found 0.13 in exit gradient B. So we will similarly we will calculate B and found a number of drop per LB equal to 3.8. 3.8 is given in the figure 3.8. So we found 0.13. We can solve this equation, solve this problem in another way, which is we know the ND is given, H1 is given, H2 given, N of is given, ND is given, K is given. So the head loss of each potential A delta H H1 minus H2 ND is 0.57. At point A, we have to go through the AC potential drop. So the water is piezometer will be rise and the elevation H1 minus delta H, and we will multiply 1 because we are calculating from point this point. That's why we will multiplying 1 and found 0.583. At point B, we have a 5 point in potential drop. So we can see here 5 point 1 2 3 4 5. So the water, that's why we will multiply 5. So the water piezometer will rise above the sea level 5 into H1 minus 5 into delta H and found 2.0. And total rate of flow seepage we know the Q equal to K equal to A and F equal to H1 minus A, H1 minus H2 into ND, and found 0.0825 meter second per meter. So the average hydraulic rate at C can be given. We can see the head loss per drop and average length of between D and C, and found given in figure and found 0.13. Okay, so let's see another example. Here is another example. So before we going to the example, so we know the we have to read the question. The question is for the weir shown in figure 8.2. This is to and calculate the seepage in permeable layer, cubic meter depth per meter, x prime in 1 meter, b x prime 2 meter, and use this figure. So this is this figure we have to use. So uplift pressure and hydraulic structure ND we know is 7 and NF equal to 2. ND equal to 7 because 1 2 3 4 5 6 7, and N2 equal to 2 1, and another is 1. This 2 portion is water is going through, and head loss per potential drop H1 minus H2 in ND equal to. So H is 7. We can see here. Head loss per head we can see at point 1. So this is the point 1. We can see point 1, and H1 plus 2. Here is a 7 plus 2 and minus 1 because this is the first point. That's why minus 1. And for 2 for point B we will minus 2 because this is the point 2. In the same way, the third is C is minus 3, and consequently F equal to minus 6. So we have found this. Now we'll calculate the uplift pressure at A equal to, we know the actual pressure is 8 equal to gamma S. So we will multiply this into gamma S and found this equation. We all throw is multiply this in gamma S, which is a unit weight of water. So now we'll figure drawing the figure. We can do the 8, 7, 6, 5, 4 and 3. The point 3 for F, 3 for F and 8 for A. So now we'll calculate the force. How we'll calculate the force is nothing but it is a trapezoidal rules, which is the sum of the between 2 points and height. Height is nothing but 2.8. We have no the 2.8 and 7 into 8, 7 into 8 divided by 2. So we'll taking the average, which is the trapezoidal rules, and consequently F2, F3 and F5 we have found 9.6. The total force will be the summation of the all total is total force, and found 77.2 and gamma equal to 9.81 and found 757.33 kN. So flow rate Q equal to K into H by H divided by ND and NF, and found 0.1 cubic meter per length, and K is assumed 5 by 100. So gradient between B and C, we I equal to H divided by ND into L. L is we assume 30 meter and found 0.03. And weight of concrete we know B equal to B into unit weight, and B is nothing but BD into H cross section into height, and found 1752.3. Factor of safety we know weight of the dam we have found 785, and total uplift pressure of dam 757, and it is the greater than 1. So we can say this is the okay. So we can see another example for here. The flow net of the around the single flow rate sheet pile in permeable soil layer is shown figure, and K equal to given 5.8 to seepage, and how the height is above ground level, the water will be rise piezometer are placed at the point A and B. Here is A and B, and the total rise of seepage through the permeable layer per unit length, and the approximate average hydraulic dam grade point at A. From the gradient and from the figure we can know ND equal to 6. How we'll know? Because the 1, 2, 3, 4, 5, 6. This is the 6 sips of drop, number of drop. 1, 2, 3, 4, 5, 6. This is the 6 point of the drop, and NF equal to 3 because the 3 channel, 1 channel, 2 channel, and 3 channel. 3 channel water is flowing in the 3 channel, and in this way now we'll calculate H1 equal to we have been seen here 5.6, and H2 equal to is 2.2, we have been seen here, and gamma. So delta H equal to H1 minus H2 equal to number of drop, which is 5.576 meter per drop. At point A we will see H1 5.6 and 1. 1 is because this is the we can calculate from left to right. This is the 1, and number of drop 0.566, and point B will multiply 5 because the 1, 2, 3, 4, 5. This is the number of 5. That's why we will multiply the 5. And Q equal to 2.38 Ks H1 minus H2 and ND, and found 6.74 10 to the minus 5. And for C gradient and I equal to we know the H1 minus H2 and D equal to L, and found 0.13. So we can see another example, a flow net for flow around a single row of sheet pile in a permeable soil is shown figure. This is the shown figure, and K is also 5 into 10 to the power minus 3, meter per second. Determine the total rate of seepage through the permeable layer per unit width. So we can see the H1 is height is 15 meter, and the another one H2 equal to 5 feet. So number of flow line 1, 2, 3, 4, and um, um, number of drop 1, 2, 3, 4, 5, 6, 7, 8. So number of drop will be 7. And number of drop, how will calculate the number of drop? How many segment? This is the 1, 2, 3, 4, 5, 6, 7, 8. This is the segment. How many segment we will divided the flow line? So so H1 H equal to H1 minus H2 and found 3.03, and Q equal to we know K into H equal to NF divided by D, and found 7.6 to 5 in 10 to the minus 3 cubic meter per second. So let's see another example. So the deposit of cohesion soil with the permeability of 9 into 10 to the minus 6 centimeter per second. So this is centimeter, we have to remember, and has a depth of 10 meter with a permeability impervious layer below, and the sheet pile wall is driven into the deposit in the depth of 7.5, and the wall extent above the surface of the soil is a 2.5 meter depth. Water act on the site. Sketch the flow net and determine the seepage and quantities per meter length of the wall, and figure given below. This is the figure we have been shown. So number of flow 3. How we will calculate 3? 1, 2, 3. So how many channel water is flowing, water is going, or water is penetrating, we can say. And number of drop nothing but how many segment we have found, like this, and this portion is one segment. This is this portion, between two portion is 2, and 3, 4, 5, 6. So this is the number of drop is 6, and H equal to H1 minus H2 is 0, that's why 15. K2 is K2 given in centimeter, now we'll convert in meter, and Q equal to K into H minus H into NF divided by ND, and found 3.75 in 10 to the minus 4 meter second per meter. So we can see this is the last example. So we can see the earth dam shown in figure below, given alpha equal to given 30 degree and beta equal to 45 degree, B equal to 10 feet, and H equal to 20 feet, and height of the dam we can see here the 25 feet, and K equal to the permeability coefficient 2 into 10 to the minus 4 feet per minute. Calculate the seepage rate Q in feet per day per feet of the land. So you can see that here is the figure. The breadth is given in D, and B equal to 10 feet, and beta in this beta is here for 45, and H equal to 20 feet of the water height, and height of the total of the dam is 20 feet. So we will use tan theta equal to height into length, and tan theta equal to 10 beta H divided by delta. H is here, and delta is this portion. So in this way we will calculate delta 1 equal to 20 feet. So this is this length of delta is 20 feet. In the same way we are calculating this delta because the water portion is here. On the other hand, we will calculate this portion of delta in the same way, tan equal to height into length. So we will use height is 25, we can see here 25, and tan equal to 30 here, and delta 2 is found for 43.3 feet. So now we will 0.3 delta 1 in equal to delta 1 we know the 20 feet and 6 okay 6 feet. Now we'll calculate D equal to 0.3 delta 1. This is the 6 feet, and height of the dam minus height of the water into 10 beta plus B plus del 2. This is the big worm, that's why delta 2, and we have calculated 6, and height of the dam we know 20 and minus 20. 20 is a water height, so this is the beacon side, and then 25, this is the angle of the left side, and B is we know the 10 feet of the dam, and 43.3 we have found the delta 2, we have already calculated here, and found 64.3 feet. So this is the dam width, we can say D, this is the D, the 64 point feet. Now we'll calculate the L equal to D by cos alpha minus root over D square cos square alpha minus H square sin square theta. So we'll calculate 11.7 feet. Now we'll calculate the permeability, seepage rate. The Q equal to K is 10 alpha into sin alpha. So K we have no 2 into 10 to the power 10. It is given here 10 to the minus 4, and L we have found 11.7, and 10 theta is found 30 degree, and sine also 30 degree, and found totally the result in 1.973 feet cube per day. So the lecture is ended here. If you have any question, then let me know. I will try to solve your questions. Thank you everyone. Thank you.